Hello, this is Mrs. Kidman, and we are going to be talking about piecewise functions. So what are piecewise functions? Well, piecewise functions are a function that's defined by two or more equations. Now, a quick review about functions. Remember that a function means that for every x value that I put in, there's exactly one y value. So oftentimes, as we're learning about functions initially, we look at it and by looking at these points of x and y, and for every value in our x, it only goes to exactly one y value. The other way that we look to see if a set of lines or a graph is a function is it has to pass something called the vertical line test. So what that means is if I have a graph of a line here, some sort of thing that might look like this, what happens is as I look at the graph, anywhere that I draw a vertical line, I should only hit that blue line exactly once. If I hit it more than once, then it's not a function. So for example, here are two different lines. In blue here, we have a line that looks like this. Now that line is a function because no matter where I look at it, it's only going to hit once. However, this green line here is not a function because when I look right at 0, 0 here, you can see that it actually crosses at 2 points if we look at a vertical line. So that means that blue one is a function because it only crosses once at all those lines, but that green one is not a function because it does not pass the vertical line test. So these piecewise functions are two or more equations put together to create a function. So that means that the domain, or all the x values, are represented, but they might be represented by different equations. So let's look at this example below. Here we have f of x equals x minus 2 if x is less than or equal to 0, or 2x plus 1 if x is greater than 0. Now, this is important for us to be aware of, this greater than 0 or this less than 0, because that tells us when the function is going to look like that. So this first part, when x is less than or equal to 0, means that anywhere where x is less than or equal to 0, so that's going to be this whole side of our graph here, anytime one of our values is over there, it's going to be following this line, x minus 2. And we can see that that's what's been graphed here, that we have x minus 2 graphed right here. And that goes all the way until we reach 0. But as soon as we go past 0, what happens is our function actually changes. So here, when x is greater than 0, our function changes to 2x plus 1. So we're going to pop up and we're going to look at 2x plus 1 as soon as we're looking at those x values greater than 0. So those are the ones all on this side. So even though there are two different lines and they look like they're disconnected, right here, we can see that it still passes the vertical line test because this open dot means that it comes as close to a 0 as it possibly can, but it does not include it. Therefore, this is still a function. Now, we are going to be looking at a couple different ways that we can deal with piecewise functions in the future videos. So we're going to be talking about how to evaluate piecewise functions, how to graph them, how we would write them when we're given a graph, and how to apply them in the real world. So tune in to learn about all these different things we can do with piecewise functions.